Good afternoon, everyone, and thanks for joining us on this December edition of the Standard Motor Products Pro Training Power Hour. Today's topic will be diagnosing false ABS activation. My name is Marc Dufort, and I'll be your host, along with my good buddy Corey, who's also in the studio this afternoon as your co-host. We have a limited amount of time together, so let's get to it. All right, so again, our topic for this afternoon is going to be diagnosing false ABS activation. But in order to be able to diagnose false ABS activation, we have to understand a little bit about how that works. One of the main components is, of course, the wheel speed sensor. And there are two types that we're going to get into, passive and active. Now, we also have a couple of props in the studio this afternoon, and I'm going to demonstrate how a passive wheel speed sensor works. And then, of course, on the bench behind us, I'm going to show you what an active wheel speed sensor looks like as well. We're going to talk about some of the installation tips and techniques and some of the things you want to look out for when you're installing these bearings. All right, so let's get to it. Now, again, we're going to start with wheel speed sensors. Currently, we have two categories, passive and active. Knowing which type of sensor you have is important because your diagnostic strategy is going to change somewhat depending on which sensor you have. All right, passive wheel speed sensors are variable reluctance sensors and are essentially just a magnet within a coil of wire. The sensor generates a magnetic field, and as a reluctor cog, or tooth, on the ABS tone ring approaches the sensor, the magnetic field expands. And as that cog passes the sensor, the magnetic field collapses. Now, as this field changes, it induces an AC voltage into the sensor. And as this AC signal increases or decreases in frequency based on the speed of the cogs or teeth, the ABS module will take that information and convert it into speed. Now, this type of sensor does not require power to operate. The signal strength is dependent on speed, which makes them ineffective at very low speeds. Now, one test you can perform is a resistance test using a multimeter. Specifications, of course, vary between manufacturers, but generally speaking, you should see about 1,000 to 2,500 ohms. Now, one very important note about all of these types of sensors are that the air gap is critical. That air gap is the spacing between the sensor and the reluctor cog. All right, here we have unplugged the sensor and attached our probes across the two wires. This test proves that a sensor is bad if a high resistance is measured. However, it does not prove the sensor is good. This is where a scope comes in handy. Now, I know that not everyone uses a scope, and that's okay. However, it makes for a great visual on what is happening with the signal. With our scope connected across both wires, when you spin the wheel or hub, you will see an AC voltage wave. If you were to perform this test with a non-graphing multimeter, you're only going to see an average voltage. Using the min-max function will give you a high and a low, but not what the actual signal looks like to a module. All right, we chiseled off one tooth cog to see what the actual scope pattern would be. Here's the scope pattern acquired from the sensor on the wheel with the missing tooth. And as you can clearly see, the scope pattern identifies a gap in the signal. Our multimeter does not show a noticeable difference. In other words, it is not obvious. This is also why visual inspection is so important. So we're going to go back to our bench and we're going to actually demonstrate a little bit about a passive sensor of this type. You'll see on the bench in front of us, we've got our multimeter. It is set to AC voltage. It's already hooked up to my sensor. Now, the sensor, as you'll see, it's not a wheel speed sensor, all right? But the concept is the same. This could very well easily be a crank sensor or a cam sensor. We've also got a cog. This is from a camshaft with teeth. And we're going to demonstrate that we have no power hooked up, and as each tooth passes through the magnetic field, it generates an AC voltage. Now, the air gap here is critical. This magnet is pretty strong, and I can actually just let it sit there. That's how strong that magnet is. So it's difficult for me to hold it at the correct distance because it has to be so close. We're going to demonstrate now. I'm going to try and hold this as close as I can. What I'm going to do is I'm going to spin it first and then try to close in. This seems to work the best when trying to perform this kind of demonstration. And as you can see, I have to get fairly close, and I have to have some kind of speed built up to generate an AC voltage. At lower speeds, it doesn't do anything. So this is why they work down to a certain speed, typically 6-7 miles an hour, and then after that, you'll see the sensor drop out if you're using your scan tool to diagnose some of these sensors. All right, so let's continue with our presentation, and we'll talk a little bit more about getting into active wheel speed sensors. Different manufacturers call these modules different things. So for the time being, let's just stick with ABS module. When the ABS module receives information from the speed sensors, and there is a difference in rotational speed between the wheels, it will make a decision. Now, this differential could be either positive or negative wheel slip. It will then share this information on the network with other modules. And if there is too great of a negative slip, it will take over the hydraulic pressure so that the correct slip ratio can be maintained. In other words, it's going to release the pressure on the brake to prevent that wheel from skidding or sliding. Wheel speed sensors and ABS status, of course, can be monitored on the scan tool. And let's face it, we're already there checking for codes, so why wouldn't you? Be aware, however, that sometimes it is not obvious where your problem lies, as scan tools all give data at different rates. Now, as technology improves, and due to those limitations of the passive wheel speed sensor, there is a need for sensors that can not only respond to low-speed situations, but even vehicle creep. Think of a hill assist system that applies the brakes when the vehicle begins to roll backwards. With a passive wheel speed sensor, it only sees a signal, but it really cannot give us direction of rotation. These new active wheel speed sensors not only give a signal at low speeds, but can also give rotational direction. Now, you can see this type of sensor as far back as 2000 when they were first introduced. Now, we're going to highlight two types of active wheel speed sensors that, for this class, we're just going to call them Type 1 and Type 2. The Type 1 sensor uses a reluctor wheel that has magnets embedded into it with alternating north-south poles that face the sensor tip. As these magnets move past the sensor's resistance changes states. The ABS module supplies battery positive on one of those circuits, and it supplies the ground to the other. It's a two-wire sensor. As the module monitors the battery positive circuit, it will see a toggling voltage according to the resistance changes in the sensor as the voltage is dropped to ground through the sensor, or the voltage is lowered. Now, understand that, yes, it's a two-wire sensor. However, it outputs a digital signal. Now, I know most of you are used to hearing, well, if it's two-wire, it's analog. If it's three-wire, it's digital. And that's not necessarily the case anymore. Okay, we have two-wire sensors that send a digital signal back to the module in charge, whether that be called an ABS module or an electronic brake control module, whatever you want to call it. Now, it's very important to exercise caution when installing these bearings. The bearing must be pressed in so the ring faces the wheel speed sensor. It's also important to use the proper adapters to press the bearing in. nothing should hit that seal area. So let's look at an example of this type of sensor that's in use on a 2013 Ford Escape that is actually on our toolbox behind us. Okay, and we've got the entire hub assembly and the bearing. And so we're going to take a closer look at it and give a few pointers. All right, so I have a sensor here. Now, this sensor is not the correct application for this vehicle, so we're just using it for demonstration purposes because it fits the bill. If you will notice, as I stick that sensor in, right about here, you'll see it poke out. That sensor, as it pokes out, is actually touching, or it's not touching, but it sits very, very close to the magnetic reluctor ring that is inside the bearing itself. This is why it's so important that we get the bearing installed in the correct direction. If it is installed backwards, well, this ring is going to be on the outside, and this sensor will have nothing to pick up. There will be no wheel speed signal that is sent to a module, and it will set a wheel speed DTC. Now, one other thing that we'd like to point out on this specific application is you can see there's also a snap ring. Now, this bearing has to be pressed in, right? So the chances of it falling out are slim, but Ford installed a snap ring just to be safe. The thing we want to point out is that their gap in the snap ring, well, that's where this sensor fits. So if you move the gap to a different location because you're not paying attention or you're in a hurry, well, the sensor, it's not going to fit through. Or, worse yet, it will fit, but because the snap ring is in the way, you won't get a reading. All right? And that's a lot of time and effort wasted to perform this kind of repair to have to do it again. One other note, make sure that you install the correct bearing. It has to have a magnetic reluctor ring in it. If the bearing doesn't have a magnetic reluctor ring, then again, no wheel speed signal will be generated. All right, let's get back to our presentation. All right, the Type 2 active wheel speed sensor works very similarly to the Type 1 sensor, except in this sensor, the magnetic portion is part of the sensor itself instead of the reluctor wheel. All right, it does have an external reluctor wheel as well. As the reluctor passes the tip of the sensor, there will again be two resistance states created in the sensor, high and low. And just like the Type 1 sensor, the ABS module monitors that signal and monitors the power that it supplies to that sensor. All right, so you can have wheel speed sensor DTCs or you can have circuit DTCs because the module is monitoring that circuit. Now, that monitored voltage, of course, is going to toggle according to the changing resistance in the sensor. And again, it is going to be a digital signal. Now, what catches some technicians by surprise is the fact that we have a digital signal coming from a two-wire sensor. You see two wires going to it, and so you automatically think, oh, well, that's an AC analog signal. No, it's actually a digital signal. The other thing that is unusual is the very low change of amplitude. This is actually a digital wheel speed sensor scope capture, and as you can see, it only goes from 500 millivolts to 1.1 volt. It is a square wave. It generates a signal. As we can see, the speed is increasing, so it works. Now, these systems, again, do require voltage to operate. In this schematic from a 2011 Chevy Equinox, one wire provides voltage to the sensor. The other wire is a ground. Now, the wire with the battery, with the system voltage, will get pulled down slightly as the wheel rotates. If we take a closer look at this, we can see that we're only going from about 11.3 volts to about 10.8 volts. You're only talking about a 500 millivolt drop. Now, other vehicles like this 2009 Jeep Grand Cherokee use 2 wires as well. And just like our Equinox, we have a 12-volt supply on one wire, and we have the signal on the other wire. Now, there are times when the sensor itself will act as a ground, which will help eliminate the third wire. Some manufacturers will still have 3-wire sensors, but don't be surprised to find only 2 wires. The first step in diagnosing one of these sensors, of course, is to verify that we've got power. Power. We have to have power to one of these sensors. And as you can see here, this one is providing almost 12 volts to the sensor. Next step is to measure the output signal of the sensor. Now, it's important that the sensor remain plugged in for this test. It needs that 12-volt supply to output a square wave. With the sensor unplugged, it will not output anything. With this type of system, a scope, once again, is an accurate method to test the signal. As you can see here, our technician has the vehicle actually lifted off the ground and is spinning the wheel by hand. We don't have to take it for a test drive. We can do this right on our lift. Key on, engine off. The ground lead of the scope goes to ground, and the positive lead will go to the signal wire. Of course, turning the wheel by hand, you can observe the digital signal that's being produced right here. And you can clearly see the wheel increasing in speed by the increasing frequency of the pattern. There are no dropouts or spikes. If I looked at this, I would call this sensor and tone ring good. Now, some manufacturers state that they measure the frequency of the current output from the sensor, not voltage. That requires a microamp probe that has to be used in conjunction with the scope itself. Now, General Motors expects to see a 7 to 14 milliamp output from the sensors used on their vehicles. Again, another power tip, it's important again that the circuit remain intact for testing. If the sensor is unplugged and a DTC is set, the module may turn off that 12-volt feed for that key cycle. That has actually tripped up more than one technician who thought, oh, I've got no voltage supply to my sensor. All right, even though we're measuring current, we can still see that we've got a digital signal that's being produced. Now, if you have a GM vehicle with a false ABS activation, it could be caused by rust on the hub. Now, for some of you that are up in our northern states, Michigan, Wisconsin, North Dakota, South Dakota, just to name a few, a false ABS activation is when the ABS activates even though there is no actual differential in wheel speeds caused by the sensor dropping out. The rust increases the air gap. It will actually push that sensor out and away. And as we saw, that air gap is critical, and it doesn't take much to drop that signal out with an increase in the air gap. Now, if we're looking at this on our scan tool, sometimes it can be difficult to spot the problem with scan data, and usually with a false ABS activation, there's no codes because the ABS module thinks it's doing what it's supposed to be doing. All right, here's that example of a rusted hub causing that sensor to have an increased air gap. And if you look, that sensor looks very much like the one I just showed you. If you can get the sensor out of the hub, which, again, for my northern compadres, I feel your pain. I know that these sensors, sometimes they won't come out. If you can get it out and there's no damage, clean everything up and put it back together. Should be okay. However, in many cases, if it's got enough rust to push that sensor far enough out, you're not going to be able to get it out without damaging it, and so you're going to have to install a new hub assembly along with a sensor. Now, if a wheel speed sensor is suspected to be bad, it's important to test the wiring, regardless of if it's a passive or an active wheel speed sensor. There's very low current or voltage that is used by some of the manufacturers. That means the harness must be able to carry that load properly. One method, disconnect the sensor and the module. Apply power at one end and a test light at the other end. This will help load test the wiring. Right? That method is something that any technician can do regardless of tooling. Okay? But it's not always easy to access that module. An easier method would be to use a sensor simulator. You can plug the sensor simulator in at the sensor connector, and it will give an input to the ABS module, which you can then view using your scan tool. All right, so now that we have the basics, let's fix one. We got a 2014 Ford Escape 2.0-liter engine, 24,000 miles. We just talked about our bearing and sensor that are on the bench behind me. So you already know what kind of sensor is used in this vehicle. The vehicle was scheduled with a concern of a vibration in the brakes, which only happens once in a while. Right? The owner states that he'd not seen any warning lamps. Nothing to indicate that it was activating. Now, the concern was difficult to duplicate, but the technician was finally able to verify that under very light braking, there was false ABS activation. So the technician ran a full scan for codes. However, there's no code stored in the ABS module, either on demand or continuous. The vehicle was road tested again while monitoring all the wheel speed sensors in the ABS module. Now, it can be difficult to see, all right, but if you look closely, the left front sensor data looks unusual at times. Right now, looking at it from your perspective, just a quick glance, and they all four look like they're doing the same thing. However, if we zoom in a little bit and take a closer look, all right, we're looking at this portion right here. This is what we're talking about. And as you can see, there's little glitches. There's little increases in the speed. All right, so I'm looking at this, and I see the wheel speed input. That tells me, all right, well, the circuit's okay. The ABS module is both receiving the input and can relay that to the scan tool. So the only issue I really see is what is causing that, we'll call it noise. All right, what's causing that noise? So performing a visual inspection, which is a good idea, of the left front wheel area, we find a recently replaced lower control arm, which begs the question, why? So after digging into the vehicle history, the technician found that the vehicle had been involved in a collision in the left front area. The sensor ring for the wheel speed sensors is part of the wheel bearing. Now, upon closer inspection of the backside of the left front wheel bearing, he found a chip that had been from damage. Looks like somebody chipped it when they were removing it and reinstalling it. Again, the bearing itself serves as the sensor ring. So the technician did not find any other issues, called the customer, advised that they needed a new left front wheel bearing because of that reluctor ring that is part of the bearing. Reinstalled everything, and the wheel speed sensor signals are now smooth, and the false ABS activation was no longer present. And of course, he took it out for a test drive while capturing data just to make sure that the repair is correct and that there are no other issues. All right, so in summary, we had a false ABS activation with no codes. We had to graph the wheel speed sensor data, and we replaced the damaged sensor ring. Now, the one thing I did not do is we did not use a scope to look at that wheel speed sensor. Sometimes you can see it on your scan tool, but sometimes it won't be obvious, and that's when you might have to pull out a scope to scope the pattern. Now, before we go, don't forget to check out Standard Brand's YouTube channel for additional resources like installation videos, quick tips, and additional product knowledge. And for more digital resources, you can check out standardbrand.com, where you can find tons of information about different product categories. You can also access our e-catalog, which is an illustrated guide. Finally, don't forget to check soon for our upcoming 2025 Pro Training Power Hour sessions. And with that, before we wrap this up, I want to ask Corey, are there any questions out there?
So we do have a couple here, Mark, and I tried to answer a few on my own, but there's a few I just want to, they're good enough that I think you need to answer them for everybody. The first one is there an easy way to tell the difference between a passive and an active wheel speed sensor just by looking at it?
Yep. Well, I wish I could give you an easy answer. If I was a young upcoming technician, I would consider a few things like, what year is the vehicle? The reason I would consider that is because after 2010, chances are almost entirely it's going to be a active wheel speed sensor. Before the model year 2000, it's almost guaranteed to be a passive wheel speed sensor. But that leaves 2000 to 2010, right? And that's what I call the gray area. That's where we have to think about a few things. Service information, of course, is going to be your best source to find out if it does indeed have a passive or an active wheel speed sensor. There's a couple things you can do. A visual inspection, like what we looked at on our 2013 Ford Escape, if there is no reluctor ring, then it's got to be an active wheel speed sensor. If there is a tone ring, then I have to ask myself, all right, well, is my sensor getting power to it? And if that answer is no, then chances are, provided that's not the problem, that is a passive wheel speed sensor. Now, again, that's just a quick and easy. If you have to be 100% positive when you're diagnosing these, so your best bet is going to be service information. All right, do we have any other questions, Corey?
Yeah, this is another good one because just because of the way it was written here, I'm curious myself. So you talked about negative wheel slip, but didn't really talk about positive wheel slip. Is the ABS system also going to be used for positive as well as negative?
That's an excellent question, Corey. And the reason we didn't talk about that is because we're talking about ABS false activation. So positive wheel slip is considered wheel spin. All right, think about, say, wheel hits some ice and increases in speed. All right, in this case, it depends. It just depends on the manufacturer. Some manufacturers may decide that, okay, we're going to apply the brakes to slow that wheel down. Other manufacturers may decide that, all right, we're going to use torque management system instead, and we're going to, say, close the throttle body a little bit or change the ignition timing or turn off the fuel injectors. Just depends on the manufacturer. Now, the ABS module is going to be a part of that because that's where a wheel speed sensor comes from. In most manufacturers, that sensor, those wheel speeds, go to the ABS module. The ABS module then shares that information across the CAN network with any other module that determines it needs that information. So, in essence, the ABS module will be part of that diagnosis into positive wheel speed slip. However, it may or may not be part of the solution to reducing that positive wheel speed slip. And I hope that answers the question. Do we have anything else from me, Corey?
Yeah, you know what? Actually, this one popped in. It's just one. Can you go back to your last slide there where you were talking about the power hours? Okay. So, and I'll answer this one, but I figured I'd just do it for everybody. They wanted to know where they find that. It's still at that same website, standardbrand.com. you look there, right about the top, you see where it says what's in your box, catalog, products, training. When you click on that training tab, it will give you the option to see Pro Training Power Hour schedule. And that's what will take you to the schedule that'll be upcoming soon for 2025. And you can also, it's not on this screen, but if you scroll down when you're on this page, the power hours we did all through 2024 are all there. So just like this one, after today, once we get the recording, we'll be able to add that to this page. So you can see this one again anytime you want, or if you want to share it with another technician in your shop, we highly encourage that. So you can find past power hours after they're done on this page, and you can find the schedule for upcoming power hours on here as well. Just click on that training tab. And that's all I've got on my end over here, Mark. So I will let you take us out. And I'll say to everyone, thanks for being here. Mark, thank you for spending some time with us and doing this for us. And yeah, I'll let you take us out, sir.
Well, it was my pleasure, Corey. Again, thank you all for inviting us into your shops this afternoon. One other thing I would like to mention is that you will see that, yes, it says register. Well, we took a snapshot of this so we could insert it into our presentation for today. So obviously that registration deadline has passed. This is now something that's going to be in previous recordings, which you can watch. So let's say that you missed it. Well, then by all means, go in and watch it after this presentation ends. And of course, like Corey said, you can go back and watch other great presentations from some of our other instructors. All right, and with that, thank you again for your time, and we'll let you get back and go make some money. Have a good day, everybody.